we've been bombarded with all sorts of reports and industry news about data center growth, capacity constraints, all kinds of power factor and quality issues that are coming.
How can you solve something that you don't know anything about? Can prudency and affordability coexist?
I think now is the time for real-time grid intelligence.
Data is everything, and AI needs data.
Hello, everyone, and welcome to Piloting the Future, a podcast brought to you by Energy Central. Here on Piloting the Future, we're going deep with the leaders, innovators, and forward thinkers responsible for not just imagining where our power future is headed, but building it day by day. In each episode, we'll go beyond the headlines to hear from the industry insiders and bold, game-changing innovators to separate the hype from reality. We have a fun episode today. We're going to be talking about the edge. And I can't think of a more appropriate time to be talking about the edge, as we've been bombarded with all sorts of reports and industry news about data center growth, capacity constraints, all kinds of power factor and quality issues that are coming at the distribution side of the grid. Just kind of curiously, what are your thoughts on the edge, and was it a pain for you when you were at San Diego Gas and Electric?
It was actually, and you talk about the items we might find, the energy items we might find at the edge today, but even 15, 20 years ago, when it was just solar, when solar was starting to increase, customers didn't even believe that there was an issue being caused by just small amounts of solar. I was at a conference where I was telling people we have to find a way to be able to monitor and maybe even control some of the impact. And people were saying, there's no such thing. You're making that up. But we showed some data. So data is magic. We showed some data, some graphs of what happens when clouds come in and clouds leave and how voltage goes all over the map. And it was expensive getting that data back then. It wasn't easy to read data that was going on the grid on each circuit. And we eventually, even way back then, had to put monitoring devices. They weren't even real time, just so we could collect the data and show that this was an issue and that something needed to be done. And that was just solar. And of course, now we have solar, we have EVs, we have energy storage, we have fleets of EVs, fleets of trucks, and we have data centers. So much activity going on at the edge that utilities and ISOs can't even see.
Exactly. I think now is the time for real-time grid intelligence. And so at the edge. And so that's what we're going to be talking about today. So fasten your seatbelts. It's time to talk about what happens when real-time intelligence comes to the edge of the grid. It's time to move from ideas to impact with our guest, Edge Zero.
Yeah, I'm going to introduce JT Thompson. He is responsible for business development in North America for Edge Zero. And we also have with us Michael Goldman. He's a principal at Apex Analytics, also joining us today. I'm really excited to get into this. JT, can you talk about what Edge Zero solutions do and how they help the grid?
Yeah, Lee, and thanks to you and Kim for having us. Really appreciate it. So really at the heart of what we do is we provide sensing technology in the form of a small piece of hardware that goes onto the distribution transformer. And really it's about providing a data set that gives you greater visibility in what we have seen as being kind of that blind spot. And Lee, you somewhat alluded to this in your intro, between what's at the home or the business in the world of AMI and what you're getting through SCADA at the substation. So we're in that blind spot, providing more real-time power quality data that can be used for a wide range of needs from the utility, right? For streamlining and being more efficient in the grid from an interconnection process, so you can get more of these distributed energy resources on the grid, for helping drive down OpEx savings because you're able to identify proactively any future outages, so you can save on truck rolls, and really starting to see issues on that, again, in that kind of that blind spot where traditionally we've had to wait for something to happen before, corrective actions could take place. We're able to do that now with the sensing technology.
How do Edge Zero devices actually work to help with an issue? And let me explain what I'm getting at. I understand that they let you know something's going on that needs to be addressed, but how do you actually address it if you're a utility and you see an issue?
It's a great question. If you don't, how can you solve something that you don't know anything about? right? I think it really kind of starts there. And, even from, I take it from the most simplistic, side of things of like just outages, right? Traditionally, utilities didn't take corrective action until a phone call, or perhaps they'll get an alert eventually, sometime later, that there's an issue on the system. Having all of the data that we're pulling back and being able to pull 1 minute granularity data back every minute on all of the power quality metrics, right? Everything from voltage and current to 21st harmonic, those types of things. It's a data set that allows them to now, especially from the operations engineering side of the house, they're able to look at it and go, wait, 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 I've got a problem here. Let me go ahead and I can take corrective action in the control room, or maybe I do have to send a truck. And if I do have to send the truck in the case of an outage, like I can better pinpoint where that outage, where I need to send that crew, and not do like our friends here had to do when Hurricane Beryl hit last year here in Houston, which is travel thousands of miles of lines to figure out like where all the cut points were, right?
When you were developing this technology and deploying it in the early days, what were some surprise learnings that you had?
So I'll take us back a little bit, because we really started in Australia, right? Roughly about a decade ago. And it was born out of necessity, right? Because Lee, as you all know, and I think really everyone here on the webcast knows that, right? Australia is kind of sending us a postcard from the future. They have 1 in every 3 homes that has solar on the roof, primarily because it's heavily subsidized. But what was happening was there were all these voltage issues that they had no line of sight on, right? You were having power being pushed back into the grid from these homes because a lot of these solar systems were oversized. And so having all of this happen, the DSOs there, or the system operators, or they call it the network operators, they had no idea what was happening. So they were able to deploy these sensors, across their footprint, and get a better idea of what was taking place and being able to take corrective action. But as we move to the US, right, the early kind of learnings has been kind of twofold, right? One definitely is from being able to see the impact that EV and battery and solar are having on the distribution systems, especially as it relates to voltage and sags and swells, but also more importantly, the wear and tear on the distribution transformer, which, as we all know, and NREL even said last year, like we're you know, basically, facing a kind of a national emergency, if you will, because of our long lifespan that's now finally kind of coming to an end on, a majority of our transformers, and the fact that we can't make them fast enough, right? So we have that problem. But then the other learning, Lee, has been like the harmonic distortions that are taking place that traditionally you didn't do anything about it until you got a customer call and you roll a truck and you pop up a very expensive sensor for 2 weeks. You hope to God you caught it, bring it back, download the data, take a corrective action, send the truck back out. You just do this iterative process. Well, we're catching the harmonic distortions and these harmonic issues early, quickly, and it's been allowing our customers here in the US that have started to test this or roll this out at scale to be able to take corrective action in a more cost efficient way, which we all know is a big thing right now, right? Got to keep things affordable. And so that's been some of the early learnings for us.
Well, that's great. Hey, Mike, can you talk about what Apex Analytics does?
Yeah, absolutely. So Apex is a boutique consulting firm. We work mostly with utilities, public utility commissions, and private businesses, and we really provide a range of services. So anything from rate analysis to demand side management program evaluation to what I really specialize in, which is reviewing and developing regulatory strategy.
Yeah. And can you talk about how you work with Edge Zero?
So our engagement with Edge Zero has revolved around helping them better understand some of the regulatory atmosphere in certain jurisdictions. And why this is important is because within regulatory jurisdictions, everybody has different priorities or motivations. And so what we try to do, and the utilities that are operating in those jurisdictions can have their own set of kind of operational issues or what have you. So what we really try to do is we try to look for where's there a good fit. So where is there an opportunity where we see kind of a bunch of different factors coalesce. So there's regulatory opportunity, there's public policy priorities, there's operational issues on the utility side. And where those all come together, that's where we advise a client like Edge Zero to go and pursue those opportunities.
Yeah, and I think it's important, Lee, for Mike, and his team, what they've been helping us with is to really understand what we need to be talking about when we're going into these regulatory meetings. And we've done a handful so far where we're just meeting with staff just to let them know that this technology exists. And that it's been proven in other parts of the world where their problems are soon to be our problems. And so, and not do it in an adversarial way, but more or less kind of educating the regulatory staff and the commission so that as we work with utilities and they want to bring this to the table as either a pilot or what we're getting ready to do with a large East Coast utility where we're going to roll it out at scale for several thousands and tens of thousands of units, like the regulators educated. There's not a learning curve now. They're like, oh, you know what? Good job. Way to be prudent. Way to be affordable. Please proceed.
You talked before about an example being by monitoring, you can know when you have an outage, for example. But that is something that advanced metering infrastructure, AMI, or advanced metering initiative, AMI, was supposed to help with. And I think that at SDG&E, it did. We were able to figure out where an outage was. How does Edge Zero technology map against AMI 2.0, which is adding a lot of functionality?
It is. It's a great point, Lee. I think what we have found is that, quite frankly, there's been a lot of promises and not a lot of deliverability on it, right? And, I think there is absolutely a future where the next generation of AMI and our sensing technology are going to coexist, and we think that should, right? Because we still look at that as being part of the billing mechanism that takes care of one of the, as one utility executive put it to me, that's my cash register. That meter on the side of the home or the business, that's my cash register, right? And so as well, it should continue to do that and be that avenue by which customer programs can be really rolled out in a very productive and efficient manner. We're looking at it more from being more of a complement, right? Because again, there's a lot that takes place between the home and the substation, and honestly, from a home to the transformer, right? Because there may be 10 homes on that line, but what's really going on the transformer? And we're starting to see that even specifically with a lot of the overloading that takes place, Lee, where we're starting to dive into the data that we're collecting, which globally is like, almost 400 million data points a day across the globe of every size, every make and manufacturer of transformer. And we're starting to see that when you're starting to couple overloading with harmonic distortion, you're actually, increasing the degradation rate of these transformers. And right, that again, that's a problem. It's kind of like the canary in the coal mine, if you will, right? And so I don't want us to ever think of ourselves as being in competition with. It's more of a complement of what's going on. And quite frankly, it kind of becomes an insurance policy to serve as an M&V for all of the things that the benefits that AMI and the next generation is really, promoting. We can help get out there and being deployed very quickly because right we can a sensor can be deployed by a person in a bucket truck in like 20 minutes, right? So it's very fast, and so where it takes 2 to 5 years for a traditional AMI deployment, we can roll out several thousand in a 12-month period, right? So we're out there already. We're already identifying kind of where some of the constraints are on the system, and it could even help with kind of determining from a planning perspective of like, okay, this is the next area we want to go to, right? We're going to deploy some technology or some programs in this area because, right, this is a hot spot.
I wanted to jump in on this point, and I bet Mike will find this interesting as well. But I was on a public webcast yesterday with NARUC, and they had produced an amazing report through Berkeley Labs on regulatory innovation sandboxes. And we know there's a lot of really good activity in Connecticut and Vermont. In fact, those were the commissioners that were on this webcast. But one of the findings from that Berkeley report that they highlighted was that the regulators know that in these eras of, this era of affordability, there are technologies deployable right now that would probably be better than replacing what's currently available. And so that was a big message that came out of that webcast, which is if we're not pushing new innovative solutions, it's like the solutions that we have to solve our next gen problems are here and deployable and may actually be better options than just replacing what we currently have on the grids for like for like. And so in this case, I was really interested with the Edge Zero story, and especially thinking about some of those utilities that may still be in AMR. I know a few of them, and they want to leapfrog to be able to grab the benefits of this real-time data intelligence. What do you guys think about all that? Are you able to help this affordability and speed issue with this shovel-ready technology? It's ready to go, in this landscape. If I'm a utility, what should I be thinking about as I go to maybe replace the upgrade or look to other technologies that could solve some of these issues at the edge?
Yeah, Kim, it's interesting you mentioned AMR, because we have this interesting use case where we saw a utility that I think was interested in getting more granular data. They wanted more visibility into their low voltage system, but they had existing AMR meters. And when they went forward to the commission to try to put forward an AMI proposal, the commission basically rejected it because they said the undepreciated value of the AMR meters were too great and they didn't want to replace those meters yet. So this utility is now stuck in a little bit of a conundrum where it can't install the advanced meters, but it needs to get that more granular data. So that's, again, where an opportunity for a company like Edge Zero is so great, because they can come in and they can provide those sensors. They can help that utility get that granular data. They can get the visibility into the low voltage system. And at the same time, you haven't kind of upset the apple cart with the regulator, because you haven't gone forward and tried to propose, a multi-$100 million, multi-billion-dollar meter rollout.
Mike, what other use cases are you excited about for this technology?
Well, the other thing that I think if I put on kind of my regulatory hat, is how it helps promote public policy initiatives. And so really what I mean by that is you see a lot of jurisdictions across the country that are really pushing for more distributed energy resources, more electrification, things along those lines. And to the extent that those can potentially have a negative impact on the distribution system, having the sensing equipment that gives you kind of a heads up, so it allows you to get ahead of these issues before they become an outage or something like that. It actually allows you, I think, to implement these public policy initiatives a lot better, because you're able to put more load on, you're able to have more DERs, and you're able to do that in a manner without overstressing the grid. And then if there are potential issues, you know about them ahead of time, and you can come forward with whatever the solution needs to be.
JT, what's been the biggest success so far?
It started in Vermont, right? It's funny Kim brings that up. We started with one of the second largest utility in Vermont Electric Cooperative, was our first foothold, and their COO, who's actually become a good friend of mine, who I absolutely adore. He told me, right, we rolled out around 45 units in a part of their footprint where they had AMI, but they also had a lot of early enrollees, if you will, early adopters of EV and solar on these three small islands that sit right in the middle of Lake Champlain. So it's a remote area. They're seeing a large member interest in interconnect requests. They had no idea what was going on or the impacts, and AMI wasn't going to give them more than just usage, and wasn't going to give them like real time 1 minute granularity every minute type of thing. They were getting 15-minute interval data at end of day type of thing. And so we deployed it. They were able to catch several different voltage issues that they were able to take corrective action on. One was actually on a water treatment facility, but Peter mentioned to me, at Tech Advantage earlier this year, he said, "Hey JT," he goes, "just to give you a heads up." He goes, "We rolled those 45 units out." He goes, "It paid for itself within the first 9 months." He goes, "So I'm a big fan of you and you guys and the treatment that you have of working with us and consulting with us to find the right locations, et cetera." He goes, "But most importantly," he goes, "because of the issues we were able to identify proactively and take corrective action, we were able to limit the truck rolls, which is a cost savings, which has now paid for the project." And I was like, "Sweet. So when you putting your next order in?" Yeah. So there's that. And then, like I mentioned, we have a large East Coast utility that has, we're in the scoping sessions now around identifying all of the different use cases. And there's quite a bit. And there's actually some new ones that have come to pass even now around being able to take all of this power quality data that we're capturing and providing it back to their CNI customers as a value add, right? Of like, hey, here's how we're performing, but also to be able to get a better feel for what those customers are doing, if they're participating in markets, like how it may be impacting their system, good, bad, or indifferent. And so we're going to be looking at proposing from a regulatory standpoint, like a multi-year large deployment on this. And so I think at the end of the day, we even have one of the national labs has it installed now that they're doing some testing to help do maybe some initial identification of transformer failure, right? To be proactive and identify, like, not necessarily leave it that, hey, tomorrow at 2:53 and 30 seconds, this transformer is going to fail, but saying, hey, this transformer is a much greater risk of failure within this time frame. So again, from a utility standpoint, I can go take corrective action. I can make sure I have enough inventory. If not, I need to put my order in. The workflow management becomes more efficient and streamlined. And so benefits to that, that side of the coin. But we're starting to get more and more interest from utilities, which, has taken a while, and that's the hard part of leading a business that, granted, the technology is not new. As I mentioned before, it's been in Australia for almost a decade, right? These guys are using it. It's deployed at scale at, soon to be 8 of the 11 DSOs over there. But it's still new to the US. And it's still a new market that you have to create. And with any startup, right? And you guys have talked to a lot of startups, you're probably singing the same song, is that you have to create a sense of urgency. You have to to speak to their pain and understand that the sales cycle is long. And for us, right, and just me personally with Edge Zero and everything that we're trying to talk with utilities about, it's taking it from, say, the first half of last year when we really started, of people seeing it and going, dude, that's really cool. That'd be a nice to have, not necessarily a need to have. To now folks going, oh, you know what? I need this, right? I am seeing harmonics issues, and I can use this as a low cost power quality monitor that I can then identify issues if it's line side or load side, and take corrective actions. And so, right, and I've got 10,000, interconnection requests in the queue. I need to do this a lot faster instead of waiting on modeling and all of this. Like, it's like a real-time dynamic hosted capacity map, right? So, we're getting there, right? And I kind of like to say, as I've been saying to the rest of the leadership team, is like, we got a lot of wind in our sails right now, right? We got a lot of good positive momentum, and we're looking to to capture that and capitalize on it.
Mike, as a longtime DER integration strategist, looking ahead 5-10 years, what do you think the biggest changes to the grid edge is going to be, and how can Edge Zero help with that?
Yeah, I mean, I think what you're going to see is this continued kind of exponential growth of devices. Everything in your home now is communicating. It hooks up to the internet. It's potentially controllable. And so I think combining some of that capability, so flexible load, also with what the visibility that the Edge Zero device gives you down to a more granular level of the distribution system, kind of combining those two things are going to be extraordinarily, I think, helpful. I think one of the things we haven't talked about too much right now is that transformers are in short supply, long lead times for transformers. And so if you can combine visibility, that you're approaching a thermal overload on a transformer or something like that, and you can then dispatch some of these connected communicating devices behind that transformer to lower the load and maybe extend the life of that transformer. I think that's going to have, potentially very positive impacts and opportunities.
Let's move on to the visionary's take. And this is what I like to say. Kim wants to cut through the BS and gets right to the point. So JT, this section was made for you, my friend. How do we get out of pilot HELL toothpicks and into production paradise? So from what I've been hearing on the call today, and like one thing that has been top of mind with me as you all have been talking, has this power quality may have been a nice to have. We are entering a future with data centers, servers that need to be completely uninterruptible. We all have all these gadgets in our homes now. Is power quality becoming the thing that might actually scale this as we start to push more of these data centers? Or is there a need now for more of this more granular data? It seems to me like it's a pretty important piece of the puzzle, in addition to being able to say things like extending the life of the transformer and the supply chain problems. But as a data geek and power quality geek, like I kind of feel like, is it time?
I absolutely think it's getting there, right? And I think the power quality side has always been kind of a, to your point, it's been a nice to have, but it's beyond just the data centers. I think that's where the data centers definitely get their lion's share of the press, right? I just saw an article yesterday about, Encore having 200 gigawatts of interconnection, requests sitting in the queue, and I think it was like two-thirds or three-quarters of it is data centers. It's like, wow. So yes, rightly so, they should get their fair share of the press. But right, a lot of utilities will tell you that power quality is important to really any type of commercial and industrial customer that has any type of motor or drive or process, right? We've seen it in the oil and gas. Some of our first deployments here in Texas are actually on oil and gas sites, right? Because what is the one thing that an oil and gas company does not want? Lost production. What causes lost production? When that damn pump ain't turning. So like, right. So, right. Having them, having a greater line of sight, more real-time sight on what's really causing any type of distortion or imbalance is becoming more of a critical need, right? And we have been able to start to find a niche where cost effective, from a cost benefit standpoint, we're real time. We can be deployed one time and it's there for 15 years. So when you're taking corrective action, you can see in real time what's happening, right? Like if you're doing CVR or VVO, right? You can turn the dial, so to speak, and see like, hey, this is working. Okay, great. Oh, it's not working. We need to try something else. So yeah, I think that's going to be, one of the things, that, to your point, Kim, where we're going to see, a more, amiable environment for adoption of the technology, and getting that need to have versus nice to have. I think that's right.
I mean, you know a little bit about what we do in the Innovation Works hangar. So I was looking at this morning because I knew we were having this talk today, but we just generated 6,000 challenges across the industry. I matched those 6,000 challenges to figure out what utilities were working on the same things. It was 25,000 matches across the 6,000 challenges. But the ones that kept coming to the top are, I feel like, an Edge Zero sweet spot. All the DER integration, the backflow problem came up in the top 10. So bidirectional issues now, DERs, all the EV putting load on the grid, this transformer supply chain problem. All of the things you guys are solving are basically the top challenges that utilities have. And so, we were talking about the barriers and how to remove them. Maybe a stacked business case, right, JT, where you and Mike are coming in and talking about all of the benefits that you can get on top of this very, affordable and easy to deploy technology. Seems to, like you say, pay for itself pretty quickly.
It did, and Mike, I'll throw this to you because you were the one that was kind of the one that we had a good healthy debate on it, which prompted me to write. I wrote a blog a couple months ago saying can prudency and affordability coexist? Right. And I'd love to get your take on that because you came from it from I mean, I learned from you when you were at Eversource and I was selling to you at Eversource. Right. So, I mean, this goes way back.
I think prudency and affordability, there is some kind of natural tension there, but I think that they almost have to be able to coexist because if I'm a regulator, I want to make sure that all the funds that are being expended are done in a prudent manner, that ratepayers are getting value out of it. Sometimes I understand that I have to be able to kind of, sometimes the old adage, you have to spend money to make money. It doesn't quite fit, but you have to spend money to get reliability, or you have to spend money to get the kind of the hosting capacity you need to enable some of your DER public policy initiatives. So I do think there are several messages that resonate within there, which is that a product like Edge Zeros, it provides a solution at an affordable cost. It gives you that visibility. It allows you to implement some of the programs that you want to do. The other thing that we haven't talked a ton about is really also the safety and reliability of the system, because you've got the regulators, but then you also have the utilities, the distribution utilities, and their primary focus is always going to be on the safety and reliability of the system. So to the extent that the product can help with the safety and reliability, I think that's really going to resonate with those organizations. And we talked a little bit earlier about how do you get out of essentially pilot purgatory to scale. And I think part of that, anytime you are putting a piece of equipment, a third-party piece of equipment on a utility system, and that utility is responsible for the safety and reliability of the system, as we talked about, they really need to understand kind of the technical aspects of it, the technical validation of it. They need to be very confident of it. And so in the Edge Zero example, where they've now been able to deploy at a couple different in a couple different jurisdictions, and they have some of that operational data that they can now share with other utilities to make them feel more comfortable that putting this piece of equipment on their system isn't going to have any negative impacts. Not only is it not going to have any negative impacts, it's going to have positive impacts. And that's where I think you start kind of transitioning from pilot to scale.
Yeah, before we jump to the hot seat, which is our next section that Lee's going to drive, I do want to hit the safety issue, because to me, it's the last piece of the puzzle that we really haven't talked about. Can you, JT, tell us a little bit more? Because I know that your surprise findings in Australia have proven, the value of the safety.
Yeah, and it's about understanding, where are outages, where are potential, overloads that can potentially, right. If anybody has ever seen a transformer, reach failure, it's not pretty, right? It is a very large and loud, and chemically induced explosion. And so, right, so just being able to get your arms around that, like where are the faults in the system, right? And where there could potentially be areas where, again, you don't want to send customers, but you also want to make sure that, you're getting the trucks roll quickly and efficiently to those locations, so that, right, you're getting restoration efforts up and running, quickly. And so, right, that's the major part of that, right, is again identifying the issue when it happens quickly, so you can deploy to the right area. But also, right, even kind of in the forward looking, it's just like, hey, like these are areas where there could potentially be some safety issues, right? Because and we've talked about it internally as it related to wildfire, right? I mean, I think the one thing that a lot of people haven't really talked about is that when a utility traditionally, and Lee, you could probably speak to this, probably better than any of us, right? But when the PSPS event takes place, right, there's a notification that goes out in, some time frame ahead of time, right? Whether it's, 12 hours, 24 hours, whatever the case may be. But, if you're doing an area that you're going to have to actually de-energize, and there is a large penetration of EVs in that area, what's the first thing every single one of those owners is going to do? Charge, right? They're going to charge, and then, and if that particular tank, right, is not rated to take all of that stress, and it's already at the end of life, and it's been overloaded many times, right? Like, you could potentially have a catastrophic failure that starts the one thing that you were trying to prevent, right? And so I don't think anybody wants to talk about that, but that is something that, as we've been talking, internally around, the wildfire application of this from a safety perspective, right? Of saying, hey, okay, so if you do have to de-energize an area of your footprint, right, then having sensing technology out there that is letting you understand, are there pockets that are starting to overload, and it potentially take some corrective action to maybe not necessarily turn people off, but maybe minimize the rate of charge in a managed charging type of situation where you're not stressing the system and potentially causing the one thing you were looking to avoid.
JT, congratulations. You've managed to make me even more nervous about what can happen on the grid during a PSPS event. I definitely see that potential of a great charging instance happens because of that warning. Yeah, for sure.
Well, just real quick on that, Lee, but we've already been trialing in a couple spots just that managed charging, localized managed charging, use case, right? So if you have 10 cars that, or 10 homes on a given feeder that, are enrolled in a program and, a managed charging program, and we're monitoring the transformer that's serving, those homes, we're actually able to give you kind of a real time feedback loop of like, hey, you're doing great. You've turned off half of them, the other half are still charging, or hey, you've dropping the rate of charge on all 10, like, right. And it's just a continuous feedback loop that quite honestly doesn't exist in that form or fashion today with existing technology. So it's really, providing those entities that control DERs, right? Because we don't control anything, right? We just sense and tell you if you're doing great or not, or if the house is on fire, so to speak, or not. Right. So being able to provide that bridge of the feedback loop of like, hey, great job, keep doing it, or hey, you've done all you can, but we still need more. I mean, that's where we're going in some other areas and other use and applications of the data we're collecting.
I think I'm seeing two tiers to the DR program to deal with this. One says, you can touch me, but you can't touch me during a time when there's a PSPS event coming, or otherwise I'm not signing up. And another where that's okay and you would allow it. So let's get into the hot seat. What I'm really looking for here are 30-second to 1 minute answers, and all three of you can take a turn. And sometimes I even take a turn. So the first question I have is from a worldwide, all technology perspective, 5 years from now, what's the biggest issue?
Give my 2 cents, and we've touched upon some of these issues in throughout the course of our conversation. But I think it's, can we build enough generation transmission to handle all these new loads we're seeing coming on from things like electrification, the large loads like from data centers, and then in parallel to that, so can you build enough generation transmission, but at the same time, can you essentially squeeze all the capacity out of the existing distribution system to handle that growing load? It's an issue we haven't seen in a while because growth has been flat or inching or going down in some jurisdictions because of energy efficiency, or kind of inching up ever so slightly. So a problem we haven't seen in a while. So I'll be curious to see how everybody kind of meets that challenge.
I answer it from a very high macro, global view, I guess, to your question, Lee, is it's all of the above. I think that's how I would answer it, right? It's like the multiple choice test of say, right, from college and high school. Like, it's all of the above, right? Folks are going to get to an energy transition in some way, shape, or form. But you have folks who are saying it's got to be renewables, others saying it's fossil, maybe small nuclear reactors. Like no, it's all of the above. Like that's going to still be the challenge of thinking about A, it needs to be all of the above, and B, how do we make all of the above play with one another, right? And play nice in the same sandbox, because that's really what they got to do, right? That's my 2 cents.
Well, yeah, because I think what we're seeing from Edge Zero, the story is data is the gold. Data is the new gold that's going to power the grid per se. But, is data valued? And when I look at the US, and I'm not looking to work worldwidely, but I'm looking at US, and this has kind of been a beef with me lately. But when we talk about the mismatch between capital investment in the utility industry in the US and the lack of investment in innovation just because of the sheer way the business model works, and we need that data, and that data is seen not as a capital expense. What we are not funding are the two things that we absolutely should be funding right now in this urgent new world, which is we need more data. We need more global visibility to be able to see things like Edge Zero can see as an aggregator of data. And we need more funding and innovation so that we can get this types of technology piloted in production faster.
Okay, here's my answer to the question, and I'll use it to ask my next question. Biggest problem coming up is AI. Because I know it's pretty hyped. I'm not the only one saying it, but I had a couple of friends visit, and they have this ChatGPT talk to it AI that they pay for. And almost every decision, every disagreement that we have about the facts, we saw a rocket launch. I said it was a rocket launch. They said it wasn't. They just asked ChatGPT. They actually pointed the camera at the sky, and ChatGPT told us what launch it was, where it launched from, and how many miles an hour the rocket was moving. So these are early adopters that visited me. There's going to be a time 5 years from now, I think maybe even sooner, people are naturally going to use AI to answer all the questions that they have and to use it to help do them work, yes, but just to make them more knowledgeable about things in their daily life. So that, of course, requires an incredible change to society with regards to jobs. What do people do? Energy out there, real estate, construction, lots of stuff going on. So my second question is 30 seconds. I didn't take 30 seconds, but hey, I'm asking the questions. Am I overhyping this? Is AI something that's going to have this kind of crazy impact, or is it really not going to be that much?
It's hard to say that it won't have an impact. I think the debate is around how big of an impact. And I think, Lee, you were talking about maybe one end of the spectrum, which very well could be realistic. I think yet to be seen. But it's hard to imagine it not permeating almost every facet of our life in some way or another. But I think that there will always kind of be room for the human element in that as well.
Yeah, I would agree. I would agree with Mike on that. I think the only question, I would have in that, as AI becomes, more prevalent and, who knows? I mean, granted, there's still something I just read the other day about like none of them have truly given a good business model to actually make money off of the billions and billions of dollars that are being invested in this. So there's that small problem. But what data are they using to train said models? And I think about it from a utility perspective, right? Like, what data set are you using, right? Back to Kim's earlier point and the previous question, like what data set or sets are you using to train these models so that you can operate your system more efficiently and effectively? Like, it's using AI to serve an AI data center. There's something in that whole equation I would kind of find funny, I guess. But
Yeah, my wife is an author. She's published a bunch of books, and she found out that to teach the AI, they used her books. She didn't get paid anything, and you can ask ChatGPT to write a book in her style. And the scary thing is, it will.
My dad and I wrote a book using ChatGPT and AI last year. It was super fun. But yeah, I think there's copyright infringement there, Lee, for sure. You're only allowed to take 20% of somebody's work. But JT, to your point, I almost wrote a sentence the other day in an article I was writing that was like on this whole data center thing. Will AI save AI? Will we end up having AI reading our data in the energy industry to be able to solve this AI data center problem?
I have no doubt that AI will contribute knowledge to that.
yes.
Last question. What's a myth you'd like to bust about real-time edge data?
Oh God, you teed up a really good one here. I may have to take this one first, Mike. But the biggest myth is that I think is going on right now is that the next generation of AMI is going to solve all of our problems, and it's not. And it will help, and it will certainly provide, as I'd mentioned earlier, an avenue to a gateway by which to provide more useful tools to businesses and homeowners to either use less energy or use it more efficiently, and be more knowledgeable about how they're using their energy if they care. But the promises that you see, we're hearing even directly from utilities, like kind of a little bit of the overpromise under delivered, right? And so I think that's the one myth that I would you're going to need complementary technology like ours to help with the full equation, right? So that's the one I would go after.
And I guess the myth I would want to bust is that it's all or nothing with kind of grid edge data. Either, you don't, I think there's a perception that utilities either fall into you have AMI or you don't. So you either have grid edge data or you don't. And I don't think it's that binary. I think what we've seen with like the Edge Zero device is that there is kind of a continuum there, and that you're able to do projects and you can implement technology that still gives you some of that visibility without kind of a full deployment.
So if you found this conversation helpful or inspiring, and I sure have, I hope that you can tag Innovation Force and on LinkedIn and share your own bold prediction. Tell us what you thought about the episode, and maybe tag someone or a company that you'd like to see on Piloting the Future because they're shaping our new energy future. That would be great. And of course, be sure to check out Edge Zero, www.edgezero.co. And they are in the Innovation Force Innovation Works hangar. thanks to Edge Zero, what is so great is if you're in the hangar, you'd like to pilot their technology, add their solution to your use case library, it comes with a test plan. So Lee, I think it's time we can fasten our seatbelts. This one's coming in for a landing.
And be careful out there. Data is everything, and AI needs data.